Tomorrow morning at precisely 11:36 Universal Coordinated Time, something will happen that we were told would be invisible. An interstellar visitor racing through our solar system at speeds that would make your head spin will swing around our sun at its closest approach. For months, every astronomical source you could find repeated the same story. It will be hidden behind the sun, unobservable. The most critical moment of this object's journey through our neighborhood, the exact window when any spacecraft would perform its most fuel-efficient maneuver, conveniently obscured from every telescope on Earth. But 4 days ago, on October 25, 2025, an amateur astronomer pointed their equipment at the sky and captured something that changes everything. The object they were told would be invisible, sitting right there. Visible, observable, next to the sun in broad daylight. Either every major astronomical institution got their calculations catastrophically wrong, or someone wanted us looking the other way. Tomorrow we find out which. Tonight we're going to explore what might be the most significant astronomical event of our lifetime. We'll examine the science behind 3I Atlas III, confirmed interstellar object to pass through our solar system. We'll investigate the suspicious timing of institutional responses, the 8 anomalies that challenge natural explanations, and the question that keeps astronomers awake at night. What if this isn't just a comet? The stakes couldn't be higher. If 3I Atlas is natural, it teaches us about planetary formation in other star systems, about the composition of interstellar space, about the physics of objects that travel between the stars. But if it's something else, if even a fraction of the technological hypothesis holds water, then tomorrow becomes the day humanity confirms we're not alone in the universe. So settle in, take a breath, and prepare to look at the night sky differently than you ever have before. Because after tonight, you'll understand why a simple question about visibility, about whether we can observe an object at its closest approach to the sun, might be the most important question asked in modern astronomy. Let's begin. Let's start with what we were told, the narrative that was supposed to keep us calm, trusting looking elsewhere, while history potentially unfolded 200 million kilometers away. Since July 2025, when 3I Atlas was first detected racing toward our inner solar system, the official timeline has been remarkably consistent. The story went something like this. On October 29, 2025, at 11:36 Universal Coordinated Time, this interstellar visitor would reach perihelion. That's the technical term for closest approach to the sun, the point in an orbit where an object passes nearest to the star it's circling, or in this case, whipping past. For 3I Atlas, perihelion was calculated at 1.356 astronomical units from the sun's center. Let me put that in perspective. 1 astronomical unit is the average distance from Earth to the sun, roughly 150 million kilometers. So 1.356 AU is about 203 million kilometers. That's closer than Mars orbits, but farther out than Venus. A sweet spot in orbital mechanics where the sun's gravity accelerates any passing object to tremendous speeds, but not so close that the intense heat would vaporize everything. And on that exact date, we were told the object would be positioned directly behind the sun from Earth's perspective. Solar conjunction, they called it, the alignment where an object, the sun and Earth, form a straight line with the sun in the middle, its overwhelming brightness drowning out any hope of observation, completely hidden, unobservable, no witnesses. This story appeared everywhere. Astronomy blogs picked it up. The Jet Propulsion Laboratory, NASA's Navigation Center for Interplanetary Missions, included it in their tracking data summaries. Amateur observation guides warned skywatchers not to bother looking, saving them the disappointment of trying to spot something impossible to see. Even peer-reviewed papers discussing the object's trajectory included casual references to this convenient blackout period. The implication was crystal clear. Whatever happens during perihelion, whatever changes might occur in the object's trajectory or brightness or behavior would happen in darkness. We'd have to wait until early November, when 3I Atlas emerged from behind the sun to see what had changed. Trust us, they seemed to say. We'll tell you what we found. But here's the thing about trust. It requires honesty. And on October 25, 2025, at 13:25 local time, someone decided to check for themselves. The blog post appeared under the name Earth Exists, an amateur astronomy group that had been tracking 3I Atlas since its discovery. What they published wasn't a theory or speculation. It was evidence, actual telescope images, time-stamped, coordinates verified, showing 3I Atlas clearly visible in the constellation Virgo. And here's the part that should make every hair on your neck stand up. The sun was in the same frame, massive, bright, sitting on the left side of the image. The object they told us would be hidden behind the sun was instead sitting next to it, separated by a measurable angular distance, with the reference star Spica visible for positioning and Venus hanging on the right edge of the frame. Let me say that again, slowly, so it sinks in. 4 days before perihelion, when every source claimed the object would be sliding behind the sun and vanishing from view, an amateur astronomer captured it clearly visible alongside our star, not behind it, not obscured, observable. Right there. The technical details matter here because precision is everything in astronomy. The position they recorded was right ascension 13 hours, 38 minutes, 44.9 seconds. Declination negative 7 degrees 40 minutes, 32.5 seconds. Distance from Earth 2.34 astronomical units, roughly 350 million kilometers. Apparent magnitude 15. Magnitude 15 means you need a telescope to see it. It's not visible to the naked eye, but it's absolutely there, occupying observable space, sharing the same field of view as the sun, completely contradicting the solar conjunction narrative that's been pushed for months. Before anyone jumps in with explanations about angular separation or solar elongation, let's talk about what solar conjunction actually means in practical terms. When astronomers say an object is in solar conjunction, they mean it's positioned at roughly the same celestial longitude as the sun from Earth's viewpoint. The practical definition usually includes objects within about 10 to 30 degrees of solar elongation. That's the angular distance from the sun's center as measured from Earth. Below that threshold, the sun's glare overwhelms everything else. The brilliant corona, the scattered light in Earth's atmosphere, the sheer photon pressure from our star, all of it makes observation effectively impossible without specialized coronagraph equipment designed specifically to block the sun's disk. But here's what makes the October 25th observation so damning. If 3I Atlas is visible now clearly separated from the sun in the same telescopic field, then basic geometry tells us something remarkable. The object's trajectory doesn't place it behind the sun on October 29th. It places it near the sun, still at an observable angular separation, different from behind, visible instead of hidden. Which means either the orbital calculations from every major institution are fundamentally wrong, or the story we've been told about perihelion invisibility was never about orbital mechanics at all. Think about that for a moment. This isn't some minor discrepancy in predicted brightness or a small error in trajectory calculations. This is the difference between observable and unobservable, between witnesses and darkness, between transparent science and convenient narrative. The most critical moment in this object's passage through our solar system, the exact window when physics tells us any technological craft would perform course corrections to maximize efficiency, happens to coincide with a period we were told would have zero observation coverage from Earth. Just a cosmic coincidence, they assured us. Nothing to see here. Literally. Except now we know there is something to see. The question is why they wanted us to believe otherwise. On July 1, 2025, the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, first reported observations to the Minor Planet Center. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to scan the sky for potentially hazardous asteroids that might threaten Earth. They weren't looking for interstellar visitors. They were doing their job cataloging everything that moves against the background stars when they spotted something unusual. The object was faint. Magnitude 19 at discovery, requiring sophisticated equipment to detect. But it was moving fast, far faster than any asteroid in a typical solar orbit should move at that distance from the Sun. And when astronomers traced its trajectory backward, extrapolating where it had come from, they found something extraordinary. The orbit wasn't closed. It wasn't an ellipse bound to our Sun. It was hyperbolic, a trajectory that originates from outside the solar system, makes a single pass by the Sun, and continues back out into interstellar space, never to return. The third confirmed interstellar object. The third visitor from beyond our solar system that we've detected passing through our cosmic neighborhood. After Oumuamua in 2017, after 2I Borisov in 2019, we had 3I Atlas. And unlike its predecessors, unlike those brief encounters where we barely had time to point our telescopes before the objects vanished, 3I Atlas was discovered early enough to plan detailed observations throughout its entire passage. Months of study, weeks of spectroscopy, hundreds of images, the chance to characterize an interstellar visitor more thoroughly than ever before. And at the most critical moment, we were told not to look. Sometimes the most important discoveries don't come from billion-dollar space telescopes or government-funded research institutions. Sometimes they come from people who simply refuse to accept what they're told without checking for themselves. The Earth Exists Group represents exactly that spirit. Amateur astronomers equipped with consumer-grade telescopes and cameras, passion for the night sky, and healthy skepticism toward official narratives that don't quite add up. They'd been tracking 3I Atlas since late September, documenting its position night after night, comparing their observations against the predictions from professional sources. And they noticed something strange. The numbers didn't match. The position offsets were too large, the brightness was too dim, and most importantly, the predictions about solar conjunction, about the object becoming unobservable, didn't align with the actual geometry they could calculate from their own measurements. So on October 25th, 4 days before perihelion, they pointed their telescopes toward the Sun, not at the Sun directly. That would be dangerous, potentially blinding, but at the region of sky immediately adjacent to our star where 3I Atlas should be, according to their calculations, even if everyone else said it would be invisible. And there it was. The image they captured is remarkable in its clarity. The Sun dominates the left side of the frame, a massive bright disk that required careful exposure settings to avoid saturating the camera sensor. Venus appears on the right edge, brilliant even in daylight, our sister planet catching sunlight and reflecting it back toward Earth. The star Spica sits between them, a reference point that allows precise position calculations, and they're clearly visible as a faint smudge against the darkness of space sits 3I Atlas. The technical coordinates tell the story. Right ascension, 13 hours. 38 minutes, 44.9 seconds. In the celestial coordinate system, right ascension is like longitude on Earth, measuring position along the celestial equator. Declination -7 degrees, 40 minutes, 32.5 seconds. That's like latitude, measuring how far north or south of the celestial equator an object sits. Distance 2.34 astronomical units, roughly 350 million kilometers from Earth. Still approaching, still weeks away from its closest pass by our planet, but already close enough to show a faint coma, that cloud of gas and dust that surrounds a comet's nucleus when solar heating begins to sublimate surface ices. Apparent magnitude 15, on the astronomical brightness scale where lower numbers mean brighter objects. Magnitude 15 places 3I Atlas well beyond naked eye visibility. You need at least a decent amateur telescope, maybe 8 to 10 inches of aperture to spot something this faint, but it's absolutely detectable. Absolutely there. Absolutely not hidden behind the sun. The angular separation between 3I Atlas and the sun's center, as measured in that October 25th image, was approximately 45 degrees. That's significant. That's not close to solar conjunction by any reasonable definition. That's roughly the angular width of 3 fists held at arm's length, easily observable, clearly separated. And if the object was at 45 degrees separation on October 25th, basic orbital mechanics tells us what happens over the next 4 days as it approaches perihelion. The separation might decrease slightly as the object swings closer to the sun, but not by much, not from 45 degrees to 0. The trajectory simply doesn't permit that kind of dramatic alignment change over such a short period. On October 29th, at perihelion, 3I Atlas would still be separated from the sun by perhaps 35 to 40 degrees. Still visible, still observable. The solar conjunction story was wrong. Provably, demonstrably wrong. But was it an honest mistake, the kind of calculation error that happens when you're dealing with complex orbital mechanics and multiple reference frames? Or was it deliberate misdirection? A narrative constructed to discourage observation during the most critical window. The Earth Exists group didn't stop at proving visibility. They started pulling up their previous observations from October 21st and 23rd and comparing notes. And what they found was even more disturbing than the visibility lie. 3I Atlas wasn't where it should be, not according to the predictions. Not according to the careful orbital calculations from the Jet Propulsion Laboratory, NASA's Navigation Center, that tracks every object in the solar system with extraordinary precision. The position offsets reached 15.4 arc minutes on some observations. Let me put that in perspective. 1 degree of sky spans 60 arc minutes. The full moon covers about 30 arc minutes. When an object appears 15 arc minutes away from where physics says it should be, that's significant. That's a quarter of the moon's width. That's not measurement error. That's not uncertainty in the orbital parameters. That's something pushing the object off its predicted path. The brightness anomalies were equally puzzling. 3I Atlas was consistently measuring 20 to 26% dimmer than models predicted. That might not sound like much, but in astronomy, where brightness typically follows predictable laws based on distance and geometry, a 25% discrepancy is enormous. As an object approaches the sun, it should get brighter according to the inverse square law. Double the distance, quarter the brightness. Halve the distance, quadruple the brightness. Simple physics. And for a comet specifically, you also get increased sublimation. More gas and dust streaming off the nucleus. Additional brightening beyond what reflection alone would produce. 3I Atlas was approaching the sun, getting closer every day. And it was getting brighter, yes. But not bright enough. Not as bright as it should be if it were following the same rules every other comet follows. And then there were the velocity anomalies. The lateral acceleration components that required approximately 3.95 kilometers per second of non-gravitational force to explain. When a comet outgasses when ice sublimates and jets of vapor stream off the nucleus into space, that creates a tiny rocket effect. The comet pushes gas in one direction, and Newton's third law pushes the comet in the other direction. This is well understood. It's called the Yarkovsky effect for small asteroids warmed by the sun, or asymmetric outgassing for active comets. But the acceleration it produces is small, subtle, usually just a few meters per second over the course of weeks or months. You need precise measurements over long time spans to detect it. 3I Atlas was showing acceleration that required nearly 4 kilometers per second of velocity change. That's not subtle. That's not minor outgassing effects. That's something actively pushing the object off its trajectory with force that's hard to explain through natural processes alone. The October 23rd to 25th observations made this even more interesting. Over just 48 hours, the object shifted its right ascension by 3 minutes, 56 seconds of arc. That's an increase in angular velocity compared to the previous measurement period. The declination shifted 17.7 arc minutes northward, moving toward the celestial equator. Distance closed by 0.02 astronomical units, roughly 3 million kilometers closer to Earth, and brightness increased by 0.04 magnitudes, about 4% brighter. Here's where the physics gets uncomfortable for the natural comet explanation. The brightness increase they measured was more than twice what inverse square law predicts for that distance change.
When something moves from 2.36 astronomical units to 2.34 astronomical units, you expect about 0.017 magnitudes of brightening. Basic calculation. Straightforward physics. They measured 0.04 magnitudes, more than double what the math says should happen. The object is brightening faster than it should as it approaches, but staying dimmer overall than it should be. That's contradictory behavior. That's not how passive reflectors work. That's not how natural comets behave. And the angular velocity was accelerating. The rate of position change from October 23rd to 25th exceeded the rate from October 21st to 23rd. As the object approached perihelion, it wasn't just moving, it was speeding up in ways that pure gravitational acceleration from the sun's pull doesn't fully explain.
When you combine this with the persistent lateral velocity component that's been documented for over a week, you're looking at an object that moves more like it's under intelligent control than like it's following a ballistic trajectory. But before we jump to conclusions, before we start claiming aliens with certainty, we need to remember something important. Extraordinary claims require extraordinary evidence. And right now, what we have is anomalous behavior that challenges comfortable explanations, not definitive proof of artificial origin. The question isn't whether 3i Atlas is doing things we don't expect. It clearly is. The question is whether those unexpected things require technology to explain, or whether we're just witnessing natural phenomena at the edge of our understanding processes that happen with interstellar comets that we've never had the chance to study carefully before. That's what makes tomorrow so important. That's why perihelion matters. Because at closest approach, any spacecraft would make its move. Any probe would execute the maneuver it was designed for, using the sun's gravity as a slingshot, taking advantage of the Oberth effect to maximize efficiency. And now we know we'll be watching. Every telescope capable of pointing anywhere near that region of sky. Every amateur astronomer with equipment and clear weather. Every professional observatory with instruments that can handle the glare. No darkness, no hiding, just physics playing out in real time with witnesses. If this is a natural comet, we should see predictable behavior tomorrow. Brightness corresponding to outgassing rates and solar heating. Trajectory matching orbital models within reasonable error bars. Symmetric coma structure consistent with sublimation of surface ices. No further course corrections beyond what solar radiation pressure and asymmetric outgassing can explain. But if this is something else, if even 1% of the technological hypothesis holds water, tomorrow becomes very different. Let's talk about orbital mechanics. Because at the heart of the 3i Atlas mystery lies mathematics cold and precise, telling us stories about where objects have been and where they're going. When you track something moving through space, whether it's a satellite, an asteroid, or an interstellar visitor, you're essentially doing detective work with physics. You measure position at multiple times, you note the velocity, the direction, the acceleration, and then you use Newton's laws, Einstein's refinements, the gravitational influence of every massive body in the solar system to predict where that object will be in the future. The predictions aren't perfect. There's always some uncertainty. Measurement error unknown, forces tiny gravitational perturbations from distant planets. But for well-observed objects, the predictions are good, really good. You can forecast where a spacecraft will be a year from now to within a few kilometers, where an asteroid will pass by Earth decades from now to within a few thousand kilometers. The errors are small because the physics is well understood. Gravity behaves predictably. Newton's equations don't lie. Objects in space follow trajectories determined by mass velocity and the forces acting on them. Simple, elegant, reliable. Unless something's pushing them. The Earth Exists Group's systematic observations from October 21st, 23rd, and 25th revealed something that shouldn't exist if 3I Atlas is a passive object following gravity alone. Position offsets from JPL predictions reaching 15.4 arc minutes. That's not a small discrepancy. That's not the kind of error you get from measurement uncertainty or slight differences in how different groups calculate orbits. That's a quarter of the moon's apparent width. That's enormous in astronomical terms. To understand why this matters, imagine you're tracking a car driving down a highway. You measure its position at mile marker 100, calculate its speed and direction, and predict it should reach mile marker 150 in exactly 1 hour based on constant velocity. But when you check an hour later, the car is at mile marker 148, 2 miles short of where it should be. Something changed. Either the car slowed down or it took a detour or your initial measurements were wrong. One of those has to be true because physics doesn't allow cars to spontaneously appear in different locations than mathematics predicts. The same logic applies to 3I Atlas. If the object appears 15 arc minutes away from where orbital calculations say it should be, something is causing that deviation. And the something isn't measurement error, because multiple observers using different equipment are seeing the same offsets. So what could cause this natural comets experience non-gravitational forces? When ice sublimates, when gas jets stream off the nucleus that creates thrust. It's tiny, but it's real. Comets are nature's spacecraft using solar heating as fuel, ejecting mass in one direction to accelerate in another. But the thrust from natural outgassing is constrained by physics. You can't sublimate more ice than exists on the surface. You can't eject gas faster than thermal velocity allows. You can't generate thrust in directions that don't correspond to where the sun is heating the nucleus. The Earth exists. Calculations showed that explaining the observed position offsets required lateral velocity changes of approximately 3.95 kilometers per second. Let me repeat that. Nearly 4 kilometers per second of velocity change perpendicular to the sun's direction. For context, the escape velocity from Earth's surface is about 11 kilometers per second. That's the speed you need to completely break free from our planet's gravity well and coast into interplanetary space. Changing your velocity by 4 kilometers per second is enormous. That's not subtle outgassing. That's major thrust. And it's lateral. Not directly away from the sun, which is where natural outgassing thrust should point, perpendicular to the sun-object line as if something is deliberately pushing the object sideways, steering it, adjusting its trajectory in ways that simple solar heating can't explain. Could natural processes produce this? Possibly. If the nucleus is rotating and jets are active only on one side, you could get asymmetric thrust that creates lateral components. If the composition is unusual, if there are supervolatile ices that sublimate explosively rather than steadily, you might get more thrust than typical comets. But 4 kilometers per second lateral velocity change. That's stretching natural explanations to their limits. Then there are the brightness anomalies. And these are particularly troubling because brightness is usually the most reliable observable property of astronomical objects. Light follows simple rules. Inverse square law tells us that brightness decreases with the square of distance. An object twice as far away appears 4 times dimmer. An object half as far appears 4 times brighter. You learn this in high school physics. It's fundamental. It's reliable. For reflective objects like asteroids or the solid nucleus of a comet, that's basically the whole story. Brightness varies only with distance and geometry, the phase angle between sun object and observer. Predictable, calculable. For active comets, you add sublimation effects. As the comet approaches the sun, ice turns to vapor dust, gets lifted off the surface, the coma expands, and the comet gets brighter beyond what reflection alone would produce. But this is also predictable. We know how different ices sublimate at different temperatures. We know how coma brightness scales with dust production rates. 3I Atlas was consistently measuring 20 to 26% dimmer than models predicted for its distance and composition, a quarter darker than it should be. Every observation, every measurement. Persistently, systematically too dim, but it was also brightening faster than inverse square law alone would explain. Between October 23rd and 25th, as distance decreased by 0.02 AU, brightness increased by 0.04 magnitudes. The distance change predicts 0.0 magnitudes. They measured more than double that, getting brighter, faster than it should, while staying dimmer than it should. Contradiction, anomaly, mystery. How do you explain this? Maybe the nucleus is smaller than estimated, giving you the overall dimness, but the outgassing rate is higher than expected for that size, giving you the rapid brightening. Possible, but that requires a very specific combination of size, composition, and activity level that seems convenient. Or maybe something else is happening. Maybe what we're seeing isn't purely reflection and outgassing. Maybe there's a component of controlled emission, deliberate brightness variation, the kind of thing you'd see if an object were modulating its visibility for reasons we don't understand. Speculation, hypothesis, not proof, but when you combine everything, when you look at the position offsets and the velocity anomalies and the brightness contradictions all together, a pattern emerges. This object is not behaving like typical comets behave. It's not following the simple rules we expect from passive bodies responding to solar heating. It's doing something different. And that difference, that deviation from expectation, is what makes tomorrow's perihelion passage so important. Because at closest approach, at the point where the sun's gravity is strongest, and any spacecraft would make its move, the anomalies should either amplify or resolve. Either we'll see clear evidence, of course, corrections of active maneuvering of behavior that unambiguously requires technology to explain. Or we'll see conventional comet activity that brings the object back into alignment with natural predictions. The universe is about to tell us which. And unlike the last few months when we were told we couldn't watch tomorrow, we'll have front row seats. The numbers don't lie. The mathematics is neutral. Orbital mechanics doesn't care about our theories or our fears or our hopes for what we want the universe to be. It just tells us what is, and what is right now is an object that's deviating from predicted behavior in ways that demand explanation. Natural explanations exist. They're complicated. They require specific conditions and fortunate combinations of properties. But they exist. Technological explanations also exist. They're simpler in some ways, more complex in others.
They require accepting that intelligence exists beyond Earth and has achieved interstellar travel. But they fit the observations remarkably well. We're not at the point where we can choose between them with confidence. Not yet.
But we're approaching that point, and the data we collect tomorrow might tip the balance decisively toward one explanation or the other. Watch the numbers. Trust the mathematics. And remember that the universe reveals its secrets slowly, one careful observation at a time. Sometimes the most revealing evidence isn't what happens, it's when it happens. Timing, context, the pattern of events that individually might mean nothing, but collectively tell a story. October 2025 has been a remarkable month for anyone paying attention to the intersection of astronomy, institutional behavior, and the quiet preparations that happen when something significant approaches. Let's build a timeline, not of 3I Atlas itself, but of everything else that happened around it. The context that transforms a simple interstellar visitor into something that makes governments and space agencies suddenly very interested in protocols they've ignored for decades. October 1st, 2025. The United States government enters a funding lapse, a shutdown. Congress fails to pass appropriations, federal agencies cease non-essential operations, and NASA goes largely silent. Now government shutdowns happen. They're unfortunate, disruptive, but not unprecedented. During a shutdown, NASA's website stops updating. Press releases slow to a trickle. Public communications shift to skeleton crews, maintaining only critical operations. And suddenly, at the exact moment when the most significant interstellar visitor we've ever had the opportunity to study up close is racing toward perihelion, the most visible space agency on the planet isn't actively discussing it. Coincidence? Maybe. Government shutdowns don't coordinate with astronomical events, but the timing is interesting. You couldn't design better circumstances for limiting public information flow if you tried. October 16th, 2025. The Search for Extraterrestrial Intelligence Institute SETI quietly releases revised post-detection protocols. Let that sink in for a moment. Post-detection protocols. The official procedures for what to do if we detect a signal or presence from extraterrestrial intelligence. The framework for how humanity responds to first contact. These protocols were last updated in 2010. 15 years of silence. 15 years. Where SETI presumably decided the existing guidelines were adequate, that no revisions were necessary, that the procedures developed decades ago still applied. And suddenly, 2 weeks before 3I Atlas reaches its closest approach to the Sun, SETI decides it's time to update the rules. The new protocols create what critics have called a communication monopoly. They restrict who can discuss or respond to extraterrestrial contact. They centralize control over information flow. They establish clear hierarchies for announcement and analysis, ensuring that any detection goes through official channels before reaching public awareness. Why now? What changed between 2010 and October 2025 that made updating these protocols urgent? What prompted SETI, an organization that's been listening for signals for 60 years, without confirmed detection, to suddenly revise their procedures for what happens if they find something? Maybe it's coincidence. Maybe the update was planned long in advance and just happened to get finalized in October. Maybe there's no connection to 3I Atlas at all. Or maybe someone knows something. Maybe there are preparations happening behind scenes that we're only seeing the edges of. October 21st, 2025. 3 things happen on the same day, and this is where coincidence becomes pattern. First, the International Asteroid Warning Network, IAWN, adds 3I Atlas to its Planetary Defense Threat List. Read that sentence again carefully. Planetary Defense Threat List. This is the catalog of objects that might potentially impact Earth that require tracking and assessment to ensure public safety. 3I Atlas poses no collision risk with Earth. 0. Its closest approach to our planet will be roughly 269 million kilometers, nearly twice the Earth-Sun distance. There is no scenario, no perturbation, no gravitational influence that could alter the object's trajectory enough to threaten impact. So why add it to a planetary defense list designed for actual impact threats? This is the first interstellar object ever designated this way. Not Oumuamua, the first interstellar visitor we detected back in 2017. Not 2I Borisov, the interstellar comet that passed through in 2019. Just 3I Atlas. What's different? What makes this object worth treating as a potential threat when it clearly poses no collision danger? Second event, same day. IAWN announces a mandatory training exercise for member institutions. The exercise runs from November 27, 2025 through January 27, 2026. 2 months of coordinated training, starting exactly 4 weeks after perihelion. Training for what? Processing data from a natural comet. Analyzing spectroscopy that shows conventional composition. Why would you need 2 months of mandatory training across multiple institutions for something that's supposed to be routine observation of an interstellar visitor that happens to be passing through, unless the training isn't about 3i Atlas itself, unless it's about preparing for what comes next. What happens when an interstellar visitor does something unexpected? How institutions coordinate? How information gets managed? How you maintain control over narrative when evidence starts pointing toward conclusions you're not ready to publicly confirm? Third event, October 21st. The same day, amateur observers first document those systematic trajectory anomalies we discussed earlier: position offsets, brightness discrepancies, behavior that doesn't match gravitational predictions. The timing is perfect, too perfect. As if someone was watching, as if the moment the anomalies became detectable through amateur observation, institutional responses kicked into gear. 3 separate events. Same day. All connected to 3i Atlas. All suggesting coordination. All implying that people in positions of authority saw something coming and started preparing. You start to see the shape of something, don't you? Not quite a conspiracy, because that word implies secretive coordination against public interest. But something in between. A managed response. A careful preparation for outcomes that might require careful messaging. Pattern recognition is a fundamental human skill. It's how we survived as a species, noticing correlations, predicting danger, seeing threats before they materialized. Sometimes we see patterns that aren't there, finding meaning in random noise. Pareidolia, the tendency to see faces in clouds or hear messages in static. But sometimes the patterns are real. Sometimes the correlations indicate causation. Sometimes the coincidences are actually coordination that wasn't meant to be visible. The question is, which is this? And here's where we need to be careful, because it's easy to slip into conspiracy thinking, to assume that every coordinated action implies malicious intent, that every information control implies cover-up. The world is complex. Institutions act for many reasons, not all of them sinister. Maybe SETI updated their protocols because they've been planning to for years, and October was simply when the work got finished. Maybe IAWN added 3i Atlas to their threat list out of abundance of caution, wanting to demonstrate thorough tracking of all unusual objects. Maybe the training exercise was scheduled based on budget cycles and staffing availability with no connection to perihelion timing. Maybe. But when you're evaluating likelihood, when you're trying to assess which explanation fits the evidence better, you have to consider priors. What's more probable that multiple independent institutions all happen to take unusual actions related to extraterrestrial intelligence and planetary defense in the exact 2-week window before an anomalous interstellar visitor reaches its most critical orbital moment, or that those actions were connected, coordinated responses to something observed or anticipated? Occam's razor, the principle that simpler explanations are usually better, cuts both ways here. Yes, coordinated conspiracy requires more moving parts than independent coincidence. But coordinated preparation, people responding to the same trigger event with predictable institutional reactions, that's actually quite simple. If observers inside government or space agencies detected something unusual about 3i Atlas in early October, something that suggested the object might not be entirely natural, the responses we see make perfect sense. Update first contact protocols because you might need them. Add the object to threat lists, not because it will impact Earth, but because threat might mean something other than kinetic collision. Schedule training for how to handle unusual discoveries, because you might have an unusual discovery to handle. And most importantly, tell the public that the most critical observation window will be invisible, that perihelion will happen behind the sun where no one can watch. Because if the object does something that confirms technological origin, you need time to assess and coordinate before information becomes public. That's not paranoid speculation. That's rational institutional behavior when facing something unprecedented. You buy time. You prepare. You make sure all your protocols are ready before the moment of truth arrives. Except amateur astronomers broke the script. They proved perihelion would be visible. They documented the trajectory anomalies. They published evidence before institutional gatekeepers could decide whether that evidence should be public. And now tomorrow, everyone watches. Professional observatories, amateur astronomers, space telescopes, planetary probes, all of them pointing instruments at 3I Atlas during its closest approach, recording whatever happens, documenting behavior that either confirms natural origin or demands uncomfortable questions. The timeline tells us that October 2025 was different. Something shifted. Some threshold got crossed. And people who understand what crossing that threshold might mean started preparing for consequences. Tomorrow we find out if they were right to prepare. Tomorrow we discover whether 3I Atlas is just another comet, interesting but explicable, or whether it's something that makes all those October preparations look prescient rather than paranoid. The pattern is there, the timing is suspicious, the coordination is evident. What it means, what it's preparing us for, we'll know soon enough. In physics, anomalies are precious. They're the cracks in our understanding where new knowledge grows. When observations don't match predictions, when nature behaves differently than theory suggests, that's not a problem to be dismissed. It's an invitation to learn something profound. Avi Loeb, theoretical physicist at Harvard, former chair of the astronomy department, founder of the Galileo Project, searching for evidence of extraterrestrial technology, has made a career of taking anomalies seriously, of asking uncomfortable questions, of suggesting that when we see something unusual, we should consider all explanations, including the ones that challenge our assumptions about being alone. He's controversial for this. Many colleagues dismiss him as attention-seeking, as pushing wild speculation beyond what evidence supports. And maybe they're right to be skeptical. Extraordinary claims do require extraordinary evidence. The burden of proof lies with whoever proposes radical explanations. But Loeb would tell you that the burden also lies with science to actually look at the evidence, to evaluate possibilities fairly, to not dismiss hypotheses simply because they're uncomfortable. For 3I Atlas, Loeb assigns a rating of 4 out of 10 on his scale for potential technological origin. Not definitive proof. Not alien spacecraft confirmed, but significant enough that dismissing the possibility requires ignoring multiple independent anomalies that compound in ways natural scenarios struggle to explain. 8 specific observations earned that rating. Each one individually could have mundane explanations. Natural processes, unusual but not impossible conditions, the kind of edge cases that happen rarely but legitimately. Together they form a pattern that looks less like coincidence and more like design. Let's examine each anomaly, carefully weighing natural explanations against technological alternatives, remembering always that this is speculation, hypothesis not proven fact. Anomaly 1. Trajectory. Alignment. 3I Atlas approaches the inner solar system on a path tilted just 5 degrees relative to the ecliptic plane. That's the flat disk where all major planets orbit the fundamental plane of our solar system, defined by the angular momentum of the original protoplanetary disk that formed the Sun and everything around it. For objects arriving from random directions in interstellar space, distributed isotropically across the celestial sphere, the probability of happening to align this closely with our planetary plane is about 0.2%. 1 in 500. Low odds, but not impossible. Stellar systems eject debris in all directions when planets form, when close encounters between planets scatter smaller bodies, when stellar flybys perturb orbits. Most of that debris misses other systems entirely, but occasionally, rarely, something launched from another star happens to arrive, aligned with the target system's orbital plane through pure chance. That's the natural explanation, unlikely but legitimate. Or you could design the trajectory that way deliberately. If you're sending a probe to survey planets, you aim for the ecliptic. Everything interesting orbits there. You don't waste delta V approaching from above or below the plane where targets are sparse. You come in shallow, aligned with planetary orbits, maximizing encounter opportunities with minimal course correction. That's basic mission planning for any interstellar survey craft. Exactly what NASA does when designing missions like Voyager or New Horizons. Enter the system aligned with the planetary plane, maximize science return per unit of fuel expended. The alignment alone doesn't prove anything. It's the first data point. Keep it in mind. Anomaly. 2 planetary encounters. 3i Atlas passes unusually close to 3 different planets during its journey through our system. Venus within tens of millions of kilometers. Mars even closer, about 30 million kilometers on October 3rd. Jupiter within 54 million kilometers next March. The probability of a random interstellar trajectory bringing an object this close to 3 separate planets is extraordinarily low.
You're combining the probability of entering the solar system at all times, the probability of trajectory alignment that brings you near the inner planets, times the probability of timing your arrival, so planetary positions line up for multiple encounters. Loeb's calculation puts the combined probability under 0.05%, 1 in 20,000. Possible technically, but requiring very specific initial conditions that look suspiciously like targeting. Natural explanation, coincidence. Rare, but not impossible. We've detected 3 interstellar visitors so far. Maybe one of them was bound to have interesting trajectory just by chance. Technological explanation. If you're designing a grand tour mission to survey multiple worlds in one pass, this is roughly the trajectory you'd pick. Fast flyby of the inner system with Venus and Mars close approaches. Gravity assist from Jupiter on the way out to boost velocity and adjust departure angle. Efficient, thorough.
Exactly what Voyager did in our outer system. This is speculation, but it's worth considering that natural objects don't target anything. They follow whatever trajectory they acquired during ejection from their parent system, shaped by close encounters with planets or stars during their interstellar journey, arriving at our sun from essentially random directions with essentially random speeds. That most of them miss planets entirely is unsurprising. Space is enormous. Planets are tiny. Hitting multiple targets requires either incredible luck or deliberate planning. 3i Atlas hits multiple targets. Anomaly, 3 solar conjunction timing. Perihelion at 1.356 astronomical units happens to occur during the same period when the object reaches minimal angular separation from the Sun as viewed from Earth. We've discussed this already. The mainstream explanation said solar conjunction would make observation impossible during the critical window when any spacecraft would perform Oberth maneuvers. Except amateur observations proved that explanation wrong. The object is visible, but the narrative itself is revealing. Why tell us it would be hidden unless someone wanted to discourage looking? The probability of perihelion and solar conjunction aligning, this closely assuming random trajectory, is about 7% according to Loeb's calculations. Not spectacularly unlikely. But add it to the other probabilities. Ecliptic alignment times planetary encounters times solar conjunction timing. The compound probability drops into statistical improbability territory. Any one of these could be chance. All 3 together start looking deliberate. Natural explanation. We're just unlucky with the geometry. Random trajectories occasionally produce inconvenient observation windows.
Technological explanation. If you want to perform sensitive maneuvers without observation, you time them for moments of poor visibility from the target world. Hide in plain sight. Make your critical course corrections when Earth-based telescopes can't easily track you, except the hiding failed because amateur astronomers didn't trust the official narrative. Anomaly 4. The anti-tail phenomenon. From July through September 3rd's atlas exhibited something extremely rare. An anti-tail, material ejected toward the sun rather than away from it. This violates basic physics of how solar wind and radiation pressure work. Comet tails should always point away from the sun, pushed by the stream of charged particles and photons flowing outward from our star. Tails toward the sun require very specific geometry, where dust particles on highly elliptical orbits appear projected ahead of the nucleus or active propulsion overcoming solar wind.
Loeb and his colleague Eric Keto published a detailed model explaining the transition from anti-tail to regular tail in September as 3IS Atlas approached perihelion. Their physics is solid. Temperature-driven sublimation rates change with distance. Ice particles have different lifetimes depending on size and composition. The scattering cross-section peaks at certain distances where volatile survival times produce maximum optical effect. All perfectly natural processes that can produce anti-tail appearance under the right conditions. But Adam Hubbard, working with Loeb on trajectory analysis, pointed out something interesting. If 3I Atlas were an alien spacecraft slowing down and the anti-tail represented braking thrust, then the transition to a regular tail would mark the end of deceleration. Thrust turns off. Outgassing takes over. Behavior shifts from powered flight to passive coasting. The timing fits, the physics fits, and while natural explanations work, so does the technological one. Ambiguity rather than resolution. This is speculation, but consider, if you're building an interstellar probe, you need to slow down when you reach the target system. You're traveling at high velocity, maybe tens of kilometers per second, too fast for careful observation. You need to brake. And braking means thrust pointed forward in your direction of motion, producing a jet of exhaust streaming ahead of you. From Earth's perspective, watching a probe brake as it approaches the sun, you'd see exactly what 3I Atlas showed. A tail pointing toward the sun during deceleration, transitioning to a normal tail when braking completes, and natural outgassing takes over. Not proof, not confirmation, just consistency with a hypothesis that remains on the table. Anomaly, 5 nickel emissions, without iron spectroscopy of 3I Atlas's coma, detected glowing nickel vapor. This is unusual.
Comets contain metals, but usually as silicate minerals or metallic grains embedded in ice, not as vapor. Getting nickel into the gas phase requires very high temperatures, either from solar heating of a surface rich in volatile nickel compounds or from internal processes that vaporize metal. And the really strange part is the absence of corresponding iron signatures. Nickel and iron occur together in meteorites, in asteroids, in pretty much every natural solar system object we've studied. Finding one without the other suggests either very unusual composition or selective emission. Natural explanation. Maybe the object formed in an environment where nickel and iron fractionated, where different volatility or chemistry caused one to concentrate more than the other. Possible. Unusual, but possible. Technological explanation. Spacecraft hulls use nickel alloys. Stainless steel contains nickel. Batteries and electronic components incorporate nickel.
If you were building an interstellar probe, nickel would be part of the structural materials and could volatilize if exposed to intense solar heating during close approach. Not proof of artificial origin, but consistent with it in ways that make natural explanations more complicated. Anomaly. 6. Carbon dioxide dominance. The James Webb Space Telescope measured 3I Atlas composition in August and found an extreme carbon dioxide to water ice ratio of 8-1, highest ever recorded for any comet. Most solar system comets are water-rich with carbon dioxide as a minor component. The reverse ratio suggests formation in a very cold environment farther from the parent star than our Kuiper belt, where carbon dioxide ices are more stable than water ice. Natural explanation. The object formed in an ultra-cold birth environment, perhaps around a dim star or in the outer reaches of a planetary system. Its composition reflects those formation conditions. Technological explanation. Carbon dioxide is an excellent refrigerant. It sublimates cleanly without leaving residue. It's dense, easy to store, and releases energy predictably when heated. If you're designing a comet camouflage for a spacecraft, high carbon dioxide content gives you the optical signature you need, while minimizing water production that would be harder to control. This is speculation, but it's worth considering that engineering requirements might lead to composition choices that mimic natural objects while serving technical functions. Anomaly. 7. Early activation. The Transiting Exoplanet Survey satellite detected outgassing activity from 3I Atlas as early as May 7, 2025, when the object was approximately 6.4 astronomical units from the Sun. That's farther out than Jupiter. Normal comets don't become active until they're much closer, typically inside 3 astronomical units, where solar heating becomes intense enough to drive significant sublimation. Water ice needs relatively warm temperatures to sublimate rapidly. Carbon dioxide sublimates at colder temperatures, but usually still requires closer solar distances to produce detectable coma. Early activation suggests extremely volatile ices materials that sublimate at very low temperatures consistent with formation in the coldest regions of a planetary system. Or, and this is speculation consistent with deliberate design, to begin gas emission early for visibility. You want people to detect your probe, you make it visible from far away. Carbon dioxide activity at 6.4 astronomical units does exactly that. Flags the object as interesting, gets telescopes pointed in your direction, ensures tracking throughout the entire approach phase. Very convenient if you're trying to guarantee observation. Very unusual if you're a natural comet.
Anomaly. 8. Geometric emission patterns. Multiple telescope observations noted that the coma structure showed patterns inconsistent with random chaotic outgassing from a rotating irregular nucleus. Brightness distributions appeared more organized, potentially symmetric in ways that suggest directed jets or controlled emission rather than uncontrolled sublimation driven purely by solar heating. This is the weakest of the 8 anomalies because coma morphology is complex and influenced by rotation composition. Dust grain sizes all factors that can produce apparent geometry without requiring intelligence. But combined with everything else, it adds to the weight of evidence that something about this object behaves differently than natural interstellar comets should. Natural explanation, complex rotation, multiple active regions, unusual dust grain properties. All of these can create structure in the coma that looks organized without being deliberately shaped.
Technological explanation. Controlled venting directed thrust engineering that produces specific emission patterns for reasons related to navigation or communication. 4 out of 10 on the Loeb scale. Not alien confirmed, not even alien probable. Just anomalous enough in enough independent ways that the technological hypothesis deserves serious consideration rather than immediate dismissal. The counter-arguments are important. Most astronomers who've studied 3I Atlas conclude it's natural. Spectroscopy shows volatile ices. Morphology shows comet-like features. The trajectory, while statistically unusual, isn't impossible for natural ejection and subsequent interstellar journey. Every individual anomaly has at least one natural explanation, even if those explanations require specific conditions or unlikely combinations of factors. Science requires parsimony.
When faced with observations that could be explained either by well-understood natural processes or by speculative technological scenarios, you default to natural unless the evidence becomes overwhelming. We're not at overwhelming yet. We're at interesting. Worthy of investigation, demanding better data before conclusions. But here's what makes the situation genuinely uncertain. The null hypothesis, the assumption that 3I Atlas is natural unless proven otherwise, rests on the belief that technological interstellar probes are so rare that we can safely ignore that possibility when interpreting observations. If probes don't exist, if no civilization has ever successfully sent hardware between stars, then any interstellar visitor must be natural because nothing else is on the table. But if probes do exist, if even one advanced civilization in the galaxy has succeeded at interstellar exploration and deployed survey craft to catalog promising systems, then the prior probability changes. Suddenly, the technological hypothesis isn't wildly improbable speculation. It's a legitimate alternative explanation that might actually be more likely than natural arrival, given the statistical improbability of random trajectories producing all 8 observed anomalies simultaneously. This is the core disagreement between Loeb and the majority of astronomers. Not about the data. Everyone sees the same observations, the same spectroscopy, the same trajectory calculations. The disagreement is about priors, about what we assume is possible before we look at the evidence. If you assume aliens are vanishingly rare or non-existent, 3I Atlas must be natural despite the anomalies. If you assume technological civilizations are common enough that probes might occasionally visit 3I Atlas might be artificial despite showing comet-like features. We can't resolve that disagreement with philosophical arguments. We need more data, better observations, measurements that distinguish between the scenarios so clearly that interpretation becomes unambiguous. Tomorrow's perihelion passage is exactly that kind of measurement opportunity. Natural comets behave predictably at close solar approach. Brightness increases according to inverse square law modified by sublimation rates. Trajectory follows gravitational predictions modified slightly by outgassing rocket effects. Coma expands symmetrically driven by uniform heating. No surprises, no deviations beyond what physics allows for passive objects. Artificial probes have options. Natural objects don't. They can maneuver. They can deploy secondary craft. They can modulate brightness by controlling emission. They can time activities to maximize efficiency or minimize detection. If 3I Atlas is technological perihelion is when that becomes testable. The object either does things comets can't do or it doesn't, and tomorrow we'll be watching. Let's engage in a thought experiment, not claiming truth, not asserting certainty, just exploring what the observations would mean if the technological hypothesis were correct. This is speculation. Informed speculation based on physics and engineering principles, but speculation nonetheless. Keep that firmly in mind as we proceed. If 3I Atlas were an artificial probe, a spacecraft built by an intelligence that achieved interstellar travel millions or thousands of years, before humanity invented the wheel, what would we expect to see? First, camouflage. You don't send a probe between stars in a form that screams artificial to any civilization capable of observation. You disguise it, make it look natural. A comet is perfect camouflage. Bright enough to detect from distance, interesting enough to warrant observation, mundane enough that most astronomers will assume natural origin without close examination. How do you make a spacecraft look like a comet? You cover it in ice. Water, carbon, dioxide, ammonia, whatever volatiles are easy to harvest from the outer reaches of a planetary system, you shape the covering to mimic natural nucleus morphology, irregular, asymmetric, the kind of shape that gravitational accumulation produces. And when you approach a star, solar heating sublimates that ice covering naturally. You get a coma, a tail, all the optical signatures of a comet without requiring any active systems. But here's where it gets interesting. Carbon dioxide is a better choice than water for engineering purposes. It sublimates at lower temperatures, so you can start your natural outgassing earlier in the approach, at distances where you want to ensure detection. It doesn't leave residue when it sublimates, keeping your instruments clean. and it's dense enough to provide significant shielding against radiation and micrometeorites during the long interstellar journey. An 8:1 carbon dioxide to water ratio isn't what natural comets typically show, but it's exactly what you'd engineer if you were optimizing for multiple functions: camouflage, thermal control, radiation protection, and early visibility. The anti-tail makes sense in this context too. If you're decelerating, if you're using thrust to slow down as you approach the inner system, that thrust has to point forward in your direction of motion. The exhaust streams ahead of you. From Earth's perspective, that looks like a tail pointing toward the sun. An anti-tail. When do you stop decelerating? When you've reached the velocity you need for optimal observation, maybe around 1.5 to 2 AU, where you're close enough to get good data, but not so close that thermal stress becomes problematic. That's when you cut the thrust. Let natural outgassing take over, and the anti-tail transitions to a normal tail. The timing observed for 3I Atlas's anti-tail transition fits this profile perfectly. Not proof, but consistent. Planetary encounters make sense if this is a survey mission. Venus, Mars, Jupiter. 3 targets. 3 different types of worlds: a rocky planet with crushing atmosphere, a potentially habitable but currently dead world, with thin atmosphere and surface water locked in ice, a gas giant with complex moon system and possible subsurface oceans on its satellites. If you're cataloging a stellar system, you want data on as many different planetary types as possible. You plan your trajectory to maximize close encounters. You use gravity assists not just for velocity changes, but for optimal viewing geometry as you pass. The course corrections, those lateral velocity changes that require 4 kilometers per second of acceleration, make sense if you're fine-tuning your trajectory, adjusting your path to ensure you hit your planned encounter distances with each target. Natural comets don't care where they go. Spacecraft with mission parameters care very much. And perihelion timing, reaching closest approach during a period of poor visibility from Earth, makes sense if you want to perform sensitive maneuvers without observation. The Oberth effect tells us that thrust applied at perihelion at the point of highest velocity produces maximum change in orbital energy for minimum fuel expenditure. If you need to make a major course correction, if you need to deploy smaller probes that will drop into bound orbits around target planets, if you need to do anything that might look unambiguously artificial, you do it at perihelion. And you hope the geometry keeps Earth-based observers from watching closely. Except the geometry didn't hide you. Amateur astronomers proved visibility, and now tomorrow when you make your move, everyone will be watching. What might we see if the technological hypothesis is correct? Brightness spikes that don't correlate with distance or solar heating. The kind of emission you'd get from active systems from power generation or propulsion or communication arrays, activating during critical mission phases. Continued trajectory deviations beyond what natural outgassing can explain. Course corrections that adjust the path towards specific targets, changes in velocity vectors that indicate powered flight rather than ballistic coasting, geometric patterns in the coma that suggest organized structure rather than chaotic emission, jets that fire in directions optimized for thrust rather than just following thermal gradients on the nucleus surface, and possibly, though this is pure speculation, the deployment of secondary objects. Smaller probes released during perihelion, using the gravitational assist from the Sun to redirect toward inner system targets, performing reverse Oberth maneuvers to slow down and drop into bound orbits where they can conduct extended observations. If mini-probes deploy, if the mother ship hypothesis plays out, those objects might take weeks or months to become detectable. They'd be small, maybe a few meters across, moving at high velocity, initially requiring time to decelerate and settle into stable orbits. But eventually, if they head toward Earth or Mars or Venus, they'll pass through the detection volumes where ground-based sensors and space-based tracking systems operate. And when they do, identification becomes possible. This is all speculation, hypothesis, Thought experiment exploring what observations would mean if one particular explanation were true. The beauty of science is that we don't have to guess.
We don't have to argue about philosophical positions or prior probabilities. We just have to watch and measure. The universe doesn't care what we believe. It is what it is. If 3I Atlas is natural, it will behave naturally tomorrow. Conventional comet activity, predictable physics, the kind of observations that bring anomalous behavior back into alignment with standard models. If it's technological, it will do things comets can't do. And those things, whatever they are, will be recorded by multiple independent observers, using different instruments from different locations. Evidence creates its own pressure. You can deny it for a while. You can explain it away with increasingly complicated natural scenarios. But if the evidence keeps accumulating, if the observations keep pointing in one direction, eventually resistance collapses. Not through dramatic revelation, through gradual recognition that one explanation fits better than the alternatives. Tomorrow might be that moment.
Tomorrow might be when the weight of evidence tips decisively toward natural or toward technological. Or tomorrow might just add another data point, another measurement that keeps both hypotheses alive, waiting for more observations, more encounters, more interstellar visitors, before statistical patterns emerge clearly enough to resolve the question. Either way, we'll know more, and knowing more is always better than comfortable ignorance. While 3I Atlas dominates headlines with its dramatic approach, another discovery slipped into the astronomical record this summer that might completely rewrite what we think we know about Earth's neighborhood. On August 2, 2025, Carlos and Raúl de la Fuente Marcos spotted something that shouldn't exist. A quasi-satellite of Earth designated 2025 PN7 orbiting in lockstep with our planet in a way that natural asteroids almost never do. The numbers looked wrong from the start. The timing looked worse. Here's what makes a quasi-satellite different from a regular moon. True moons are gravitationally bound to their planet, trapped in stable orbits by the planet's mass. Our moon orbits Earth. Mars's moons orbit Mars. The relationship is direct, intimate, the smaller body captive to the larger. Quasi-satellites aren't bound at all. They orbit the Sun, not Earth. But their orbital period matches ours so closely that they appear to dance around us in the sky, keeping pace, staying nearby, never drifting too far away. It's a delicate balance, easily disrupted, rarely lasting more than a few centuries before gravitational perturbations from other planets knock the object into a different orbit. Quasi-satellite configurations are unstable temporary brief episodes in the longer story of an object's journey through the solar system. 2025 PN7 has been in this quasi-satellite configuration since the 1960s. Not millions of years, not thousands of years, just since the space race, since Sputnik and Apollo and the frantic push to reach beyond our atmosphere before the other side did. Since humanity started lobbing hardware into deep space on trajectories that would take them past other worlds, sometimes successfully, often not. Avi Loeb saw the orbital elements and asked a question nobody else wanted to touch. Is this thing natural, or did we make it? The paper he published with Adam Hubbard reads like a detective story written in orbital mechanics. They took every major interplanetary mission launched in the 1960s, pulled the departure dates and planetary arrival times, fed them into trajectory optimization software, and asked a simple question. Could any of these missions have ended up where 2025 PN7 is now one mission kept appearing in the results? Zoned 1, launched by the Soviet Union on April 2, 1964, intended for Venus and almost immediately plagued by failures. The spacecraft lost attitude control. Communications degraded. Critical systems started dying one by one as it drifted through interplanetary space, off course, underpowered, doomed. But here's the thing about rocket launches. They're not single objects. Every interplanetary mission consists of the probe itself, sure, but also the upper stage that gave it the final push out of Earth orbit. For Zond 1, the upper stage was called Block L, a massive cylinder of metal and fuel tanks. 3.2 meters across, designed to fire once and then drift away as space junk, except sometimes that junk doesn't just drift. Sometimes it ends up in places that make you wonder. The trajectory analysis showed something remarkable. If you trace 2025 PN7 backward through time, using the orbital elements we have now, it becomes a quasi-satellite of Earth right around 1964, the exact year Zond 1 launched. The heliocentric longitude of 2025 PN7 at Venus arrival dates matches Zond 1's trajectory with minimal deviation, better than any other Venus mission from that era.
Better than it should if this were just coincidence. The displacement calculations are even more interesting. When you compare where 2025 PN7 would have been during the Zond 1 flight versus where the Zond 1 probe itself was tracked, you get a minimum separation of about 8% of an astronomical unit in May 1964. That's roughly 12 million kilometers. Close, but not identical. Exactly the kind of separation you'd expect if the Block L upper stage failed to deliver its full velocity boost to the probe, leaving both objects on similar but not identical trajectories toward Venus. And here's where it gets technical in a way that matters. Zond 1 performed a course correction burn on April 3, 1964, just one day after launch. Mid-course corrections are normal, but they're usually planned well in advance based on precise tracking data. An emergency burn one day after launch suggests something went wrong during the initial boost phase, something that required immediate correction.
Like, for instance, the Block L stage failing to deliver the expected delta V, leaving the probe short of the velocity it needed to reach Venus on schedule. If the Block L failed to perform its full burn, the probe would have ended up on a trajectory that fell short of Venus, which is exactly what seems to have happened. The official Soviet records for Zond 1 are sparse, classified for decades. But what information survived suggests the mission never achieved its intended trajectory. Contact was lost in May 1964 with the probe somewhere between Earth and Venus off course, unable to correct drifting. Meanwhile, the Block L stage that pushed it would have continued on its own trajectory, shaped by whatever partial burn it managed before shutdown. No tracking, no interest. Just another piece of space debris in an era when nobody bothered cataloging every fragment. It could have drifted for 60 years without anyone noticing, following an orbit that brought it back to Earth's neighborhood just as we started getting good enough at detection to finally spot it. The brightness calculations support this scenario. If 2025 PN7 is a metallic cylinder 3.2 meters wide, roughly the size of the Block L stage, with a highly reflective surface like you'd expect, from 1960s Soviet engineering, the predicted magnitude matches what we observe. Not exactly. Orbital mechanics and albedo estimates always have uncertainty, but close enough that you can't rule it out based on brightness alone. The inclination fits too. When Zond 1 launched in April 1964, its orbital plane was tilted about 3.42 degrees relative to the ecliptic. 2025 PN7 right now has an inclination of about 2.44 degrees. Different, but not incompatibly so. 60 years of gravitational perturbations from Jupiter, Venus, and Earth could easily account for that shift. So we have a quasi-satellite that appeared in Earth orbit in the 1960s, matches the trajectory of a failed Soviet Venus mission, has the right brightness for a Block L upper stage, shows the right inclination for that launch window, and sits in an orbit that requires almost no explanation beyond a simple rocket stage failure during the space race. Occam's razor says this is probably exactly what it looks like. We found our own trash. Except, and this is the part that keeps astronomers up at night, we can't be sure until we get spectroscopy. We need to analyze the light reflecting off 2025 PN7 to see what it's made of. Natural asteroids have distinct spectral signatures, minerals and rocks and carbon compounds that form predictable absorption lines in reflected sunlight.
Artificial objects made of aluminum, titanium, steel, they have different signatures. Metal reflects light differently than stone. You can tell them apart if you get a good spectrum. This has been done before.
Back in September 2020, the Pan-STARRS telescope in Hawaii spotted an object designated 2020 SAR, so that looks suspicious. Similar situation. Quasi-satellite orbit appeared around Earth in the 1960s seemed too convenient to be natural. But in December 2020, NASA's Infrared Telescope facility got spectroscopy of 2020, and found stainless steel. Clear as day, turned out to be the Centaur upper stage from NASA's Surveyor 2 mission to the Moon, launched in September 1960, tumbling through space for 54 years before we finally identified it. If 2025 PN7 is the Zond 1 Block L spectroscopy will show metal, Soviet-era alloys, titanium and aluminum, unmistakable. But if the spectrum shows silicates, carbonaceous compounds, asteroid minerals, then we're back to explaining how a natural object happened to become a quasi-satellite at exactly the moment humanity started exploring space. Possible, but suspicious. The paper explicitly calls for this test. Get a spectrum. Measure the composition. Confirm the origin. Simple enough request, you'd think. Major observatories have the capability. The object is bright enough to study magnitude 15 well within range of current instrumentation. So why hasn't anyone published spectroscopy yet? Why are we 3 months past the discovery with no confirmation either way? Maybe it's Q time. Telescope schedules book up months in advance. Maybe it's weather. Maybe it's priorities with 3i Atlas eating up observation resources. Or maybe, and this is purely speculation, maybe someone already got spectroscopy and didn't like what they found. Because here's the uncomfortable question underneath all of this. If 2025 PN7 is natural, we need to explain the coincidence. Quasi-satellite orbits are rare. Quasi-satellite captures that happen during the exact decade when humanity launches its first interplanetary missions are rarer still. Natural objects don't care about our schedule. They don't wait for us to start exploring before they show up. So either we got cosmically lucky finding a natural quasi-satellite that happened to arrive during the space race, or the object is exactly what it looks like, and we're just spooked by our own reflection. But if it's artificial and spectroscopy confirms metal, we need to explain why a failed Soviet rocket stage ended up in such a perfect quasi-satellite orbit. And that requires either extraordinary luck, the Block L failing in exactly the right way to capture into resonance, or extraordinary engineering, the Soviets intentionally designing the upper stage to end up there. Neither explanation is satisfying. One requires too much coincidence. The other requires too much foresight for 1964 technology. There's a third option nobody wants to say out loud. What if it's not ours at all? What if 2025 PN7 is older than the 1960s, older than human spaceflight sitting in quasi-satellite orbit for decades or centuries? Before we noticed, and the timing is just when we finally got telescopes good enough to spot it. What if the reason it matches the Zond 1 trajectory so well is because something else was already there, already watching, and we sent Zond 1 straight toward it without realizing? Loeb hints at this in the discussion section. He mentions that 2 out of 3 interstellar visitors so far, Oumuamua and 3i Atlas, appear anomalous in ways that challenge natural explanations. He points out that if we're seeing artificial interstellar objects at this rate with our primitive detection capabilities, the implication is that such objects are common, way more common than natural interstellar asteroids, which means space is full of probes, monitors, scouts, whatever you want to call them, drifting between stars, checking in on promising systems, cataloging worlds where life might emerge. And if that's true, if the galaxy is saturated with ancient technology wandering from star to star, then finding one in quasi-satellite orbit around Earth isn't suspicious at all. It's expected. It would be weird if there weren't something keeping watch on the one planet in this system that developed industrial civilization. We're interesting now. We weren't interesting a million years ago. But put a probe in long-term orbit and wait. Sooner or later, if the planet's in the habitable zone, if it has water and oxygen and the right chemistry, something might wake up down there. Better keep an eye on it. That's the scenario that makes 2025 PN7 really uncomfortable. Not because it's definitely alien, we don't have that evidence, but because if we can't confirm it's ours, if spectroscopy comes back showing materials or construction that don't match 1960s Soviet engineering, we're left with an object in Earth orbit that predates our space program, sits in a position perfect for long-term observation, and activated or became detectable right as we started seriously looking for interstellar visitors. The timing connects to 3I Atlas in a way that feels like pattern even if it isn't proof. Both objects entered our awareness in 2025. Both challenge simple natural explanations. Both sit in orbits that would make perfect sense for reconnaissance missions. 3I Atlas on a flyby trajectory that brings it close to Venus, Mars, and Jupiter before leaving the system. 2025 PN7 in a stable quasi-satellite position where it can watch Earth indefinitely without requiring course corrections. If you were designing a 2-stage survey mission, this is exactly how you'd do it. Fast probe for the outer planets and inner system flyby. Slow monitor for the habitable world. Leave the monitor in place while the fast probe reports back. Pure speculation, but the numbers keep lining up in ways that make you wonder. The Zond 1 connection provides perfect cover. If anyone notices the quasi-satellite, blame it on Cold War space junk. Nobody checks too carefully. Nobody demands spectroscopy. It's just our trash. Embarrassing but harmless. Case closed. Until someone like Loeb decides to actually run the calculations and discovers that the trash explanation, while plausible, requires a very specific sequence of failures that happen to produce a very useful orbit. We should know soon. Spectroscopy will settle this. Metal means human. Silicates mean natural. Anything else means we have a problem. But until those results come in, until someone publishes a spectrum showing clear identification one way or another, 2025 PN7 sits in Earth orbit, watching, waiting, being exactly ambiguous enough that both explanations stay on the table. And if you're wondering why this story isn't getting more attention, why major media outlets aren't screaming about Earth's potential new moon, consider what happens if it turns out to be alien. Consider the panic. Consider the questions. If there's something watching us from orbit right now, how long has it been there? What has it seen? What is it reporting back to? Those aren't comfortable questions. Much easier to assume it's Soviet space junk and move on. But tomorrow morning, when 3I Atlas reaches perihelion, when every telescope points toward that interstellar visitor, and we finally get to watch what happens at closest approach, remember that we might not be the only ones watching. If 2025 PN7 is what the uncomfortable scenarios suggest, it has a front row seat. Perfect vantage point. Uninterrupted view. And whatever data it collects, whatever observations it makes, they won't be ours to analyze. Or sometimes the most revealing evidence isn't what people say. It's what happens to them when they say it. September 9th, 2025. The House Oversight and Government Reform Task Force on the Declassification of Federal Secrets holds a hearing titled Restoring Public Trust Through UAP Transparency and Whistleblower Protection. Not a fringe event, not a conspiracy convention. Official congressional hearing, sworn testimony, public record, covered by mainstream media, and the stories that emerged should have dominated news cycles for weeks, but instead got buried under coverage of election campaigns and international conflicts and celebrity scandals. Air Force veteran Dylan Bolin testified about an incident at Langley Air Force Base in Virginia back in 2012. He was working overnight as a geospatial intelligence specialist, trained observer, someone whose job required accurate identification of aircraft and assessment of capabilities. Stepped outside for a cigarette break. Standard procedure. Nothing unusual. Just a few minutes to clear his head during a long shift, and then a triangular craft appeared directly overhead. Silent, hovering, motionless in a way that helicopters can't maintain. Stable in a way that requires either incredible pilot skill or technology that doesn't rely on rotors or thrust vectoring for lift. He watched it for several minutes. Close enough to see details. Near enough that if it were conventional aircraft, he would have heard engines, felt rotor wash, noticed navigation lights and standard aviation markings. Nothing. Just geometric perfection hanging in the night sky above a secure military installation. Observing or being observed. Present in a way that felt deliberate. He reported it through proper channels, filed the required paperwork, described what he saw in technical language that left no room for misinterpretation. And then things got complicated. Interview with the All-Domain Anomaly Resolution Office ARO in 2023, more than a decade after the incident. Questions about details, timing, whether he could have been mistaken, whether conventional explanations fit the observation. He answered everything honestly, provided additional context, stood by his report, and then Arrow dismissed his claims. Not as unverifiable, not as ambiguous. Dismissed. Assessment concluded that his testimony didn't support the reported sighting, as if telling someone their memory is wrong makes the memory disappear. But dismissal was just the start. According to Boland's testimony, he faced reputational damage, workplace retaliation, manipulation of his security clearance status in ways that made continued employment in intelligence fields difficult, blacklisting from federal agencies he'd previously worked with successfully, career derailment because he reported something unusual through the channels he was supposed to use for exactly that purpose. Think about the incentive structure that creates. You're military personnel. You see something that doesn't match known aircraft profiles. You have two choices: report it and risk career destruction, or stay silent and hope someone else deals with it. Most people choose silence. It's safer. It's easier. It doesn't paint a target on your professional life, which means most sightings never get reported at all. And the ones that do come from people brave enough or angry enough or principled enough to accept the consequences. Boland wasn't the only whistleblower that day. Representative Eric Burleson from Missouri Task Force member played video footage during the hearing that he said showed an MQ-9 Reaper drone striking an unidentified orb off the coast of Yemen in October 2024. Classified footage leaked somehow, making its way to congressional oversight despite Pentagon preferences. The video quality is poor, typical of military sensor feeds converted and compressed for storage. But the key details are visible. Fast-moving object, spherical or nearly so. Drone launches Hellfire missile. Missile strikes target dead center. Clean hit, and the object keeps flying. No explosion, no fragmentation, no debris field. Just continued flight on roughly the same trajectory as before impact. As if a missile designed to destroy armored vehicles and fortified structures had hit nothing more substantial than a weather balloon. Except weather balloons don't maintain course after explosive impact. They rupture, deflate, tumble. This thing flew on. Burleson's question to Pentagon representatives was simple. Why are we being blocked from this information? If it's a balloon, say it's a balloon and release the analysis. If it's adversary technology, brief Congress in classified session with actual evidence and threat assessment. If it's something else, something that can absorb kinetic impact from military ordnance without visible damage, that seems like information the public and elected officials should have access to. Instead, silence. Deflection. Claims that releasing more information would compromise sources and methods. Sources and methods for what observing objects in our airspace. That's what radar and optical sensors do by design. Unless the concern is that releasing footage would reveal capabilities we don't want adversaries knowing about. Or worse, reveal that we've been observing objects with capabilities we can't explain for longer than we've admitted, and classification is the only thing preventing difficult questions about why we didn't tell anyone. The Yemen incident adds to a growing collection of similar cases. The Nimitz encounters off San Diego in 2004, where Navy pilots tracked objects performing maneuvers that violated known aerodynamics. The gimbal video from 2015 showing rotation and flight characteristics inconsistent with conventional aircraft or drones. The Tic Tac incident, where objects descended from high altitude to sea level in seconds, accelerating at rates that would liquefy human pilots. All officially acknowledged now. All released through Freedom of Information requests or leaks. All previously classified with explanations that don't satisfy basic physics questions about how these objects moved the way they moved. Representative Jasmine Crockett from Texas proposed during the hearing that many UAP sightings might be adversary technology. China and Russia developing capabilities that exceed American performance envelopes. Hypersonic drones, advanced stealth systems, electronic warfare platforms that spoof sensors and create false readings. Perfectly reasonable hypothesis. If our adversaries have technology we don't understand, yet seeing it in operation would produce exactly these kinds of baffling observations. Military pilots encountering next-generation hardware and reporting it as anomalous because it exceeds current understanding. But that hypothesis requires that adversaries have technology significantly more advanced than ours, operating regularly in American airspace without challenge or response. That's either terrifying incompetence on the part of our defense systems or terrifying capability on the part of our adversaries. Either way, it deserves congressional attention and public awareness rather than classification and dismissal. Unless it's not adversary technology, unless the objects performing impossible maneuvers aren't human at all from any nation belonging to any terrestrial military, then classification makes a different kind of sense, not protecting sources and methods, protecting something more fundamental. The narrative that we understand what flies in our skies. The assumption that Earth's airspace is under human control and everything in it has human origin. The comfortable belief that if something looks advanced, we or someone like us built it. The all-domain anomaly. Resolution Office was established specifically to investigate UAP reports systematically, applying scientific rigor, collecting data from multiple sensor platforms, analyzing incidents to determine origins and capabilities. Good mandate, necessary mission. But the office's public statements consistently emphasize that they found no verifiable evidence of extraterrestrial activity or technology. No proof that any of the thousands of reported sightings represent non-human intelligence, which could mean exactly what it says. Years of investigation. Thousands of reports analyzed, and nothing definitively alien found. The sightings are all misidentifications, sensor errors, adversary technology, experimental aircraft, atmospheric phenomena, or honest mistakes by trained observers under stressful conditions. Case closed, we're alone, mystery solved. Or it could mean that ARO operating within the classified world isn't free to discuss findings that would challenge fundamental assumptions about human technological dominance. If they have recovered materials tracked, objects analyzed data that points toward non-human origin releasing, that information requires approvals that might never come. Meanwhile, whistleblowers who saw the same things and didn't have classification constraints face retaliation for speaking publicly about experiences they're not supposed to share. The pattern is consistent across multiple cases. Experienced observer reports anomalous event. Official investigation concludes insufficient evidence or conventional explanation. Observer faces career consequences if they persist in claiming the event was genuinely unusual. Media coverage is minimal. Public interest fades. Incident gets filed away as another unsolved case in a database nobody outside security clearances can access fully, but the cases accumulate. Individual reports might be ambiguous. The collective weight becomes harder to dismiss. When you have dozens of trained military personnel across different branches, different decades, different locations reporting similar phenomena, objects that move in ways that challenge physics craft, that show no visible means of propulsion, encounters that get classified immediately and investigated behind closed doors, you start seeing pattern. David Grush, former intelligence official, testified before Congress in July 2023 that the United States government has been running secret UFO retrieval programs for decades, recovering crashed or landed craft, analyzing materials, reverse engineering technology, programs so classified that even congressional oversight committees weren't briefed. Black budget operations funded through mechanisms that hide expenditure from normal fiscal accountability. His testimony was explosive. His credentials were legitimate, and the response from official channels was complete denial. No such programs exist, never have. Grush is mistaken or misled or lying. Pick whichever explanation lets you sleep at night. Except other whistleblowers came forward afterwards supporting Grush's claims, not with physical evidence. Most of that is locked behind security protocols they can't legally bypass, but with corroboration, confirming that programs with those characteristics existed in their experience, that materials were studied in facilities they had access to, that crash retrievals happened and got covered up under legitimate classified aircraft recovery operations. Enough supporting testimony that dismissing all of it as coordinated delusion or deliberate disinformation becomes the conspiracy theory, which brings us back to transparency. If the government has nothing to hide, if UAP are all explainable through conventional means, releasing data should be trivial. Publish the sensor readings, declassify the footage. Let independent scientists analyze the evidence and reach conclusions based on physics rather than institutional preference. Transparency would end speculation immediately. Either the data supports extraordinary claims or it doesn't. Let the data speak, but transparency doesn't happen. Information stays classified. Whistleblowers face retaliation. Congressional requests for briefings get stonewalled or delayed, or given partial answers that raise more questions than they resolve, and the public is left trying to assemble coherent pictures from fragments. Leaks. Testimony from people brave enough to risk everything to say what they saw. The National Archives established Record Group 615 in response to the 2024 National Defense Authorization Act, the Unidentified Anomalous Phenomena Records Collection. Federal agencies are required to review, identify, and organize every UAP record in their custody for disclosure to the public. Deadline was September 30th, 2025, tomorrow. As 3i Atlas reaches perihelion as we potentially watch an interstellar visitor perform maneuvers that might confirm technological origin, the institutional deadline for UAP disclosure also arrives. Timing that's either perfect cosmic irony or deliberately coordinated to coincide pressure from multiple directions. But deadlines mean nothing without enforcement. Agencies can claim they're complying while releasing heavily redacted documents or withholding entire categories of records under national security exemptions. Without independent verification, without consequences for non-compliance, deadline announcements are just public relations. Show of transparency without substance. Christopher Mellon, former Deputy Assistant Secretary of Defense for Intelligence, has been pushing for UAP disclosure for years. He helped bring the famous Navy videos to public attention back in 2017, working with journalists to publish footage that forced the Pentagon to admit UAP are real and being tracked by military assets. Recently, at the Seoul Foundation event, he made a statement that got attention in UFO research circles but barely registered in mainstream coverage. The world is not ready for what disclosure will reveal. Not aliens confirmed. Not spacecraft recovered. Just not ready. The phrasing suggests he knows more than he's saying, which is expected given his background and continued access to classified briefings.
But it also suggests that whatever the truth is about UAP and potential non-human intelligence, the revelation would fundamentally challenge how we understand reality consciousness, our place in the universe. Big enough that preparations for disclosure involve more than just press conferences. You need institutional frameworks, psychological preparation, cultural adaptation to paradigm shifts that make Copernican revolution look modest. Maybe that's why whistleblowers face retaliation. Not because what they're saying is false, but because saying it before infrastructure is ready to handle public response creates chaos nobody knows how to manage. You can't tell billions of people that non-human intelligence has been interacting with Earth for decades or centuries and expect calm, rational integration of that information. You get panic, existential crisis, collapse of worldviews that structure entire civilizations. Better to slow-roll disclosure, leak information gradually. Let culture adapt incrementally, so that when official confirmation finally comes, it feels like validation rather than revelation. Or maybe whistleblowers face retaliation because they're wrong, and institutions are protecting signal from noise, preventing misinformation from contaminating legitimate aerospace research. Could go either way, but tomorrow brings potential clarification from an unexpected direction. If 3I Atlas is technological, if perihelion passage reveals capabilities that confirm artificial origin, that's disclosure from outside institutional control. No press conferences needed. No government announcement required. The data simply exists, recorded by multiple independent observers, analyzed by scientists who don't answer to defense departments or intelligence agencies. Truth emerging through observation rather than being released through controlled channels. That might be why the observation window was supposedly invisible, why we were told perihelion would be hidden. If something significant was expected to happen, if institutional actors knew or suspected 3I Atlas might demonstrate non-natural behavior, keeping that moment hidden from independent observation would prevent uncontrolled disclosure. Let the object maneuver in darkness. Collect classified tracking data. Decide how and when to share information based on what protocols demand rather than what telescopes revealed. Except amateur astronomers proved the darkness was illusory. Perihelion is visible. Observation will happen. And whatever 3I Atlas does tomorrow becomes public record immediately. Impossible to classify retroactively. Available for analysis by anyone with expertise and interest. Sometimes the most important disclosure isn't official statement. It's just careful observation of reality. Letting evidence speak for itself. Trusting that truth needs no institutional permission to exist. October 24th, 2025. Avi Loeb appears on the Joe Rogan Experience, one of the world's most widely distributed podcasts, and drops a detail that barely registered in headlines, but should make anyone who understands its implications sit up and take notice. The Galileo Project, his initiative to search for evidence of extraterrestrial technology using scientific methods rather than anecdotes and speculation, just completed installation of an all-sky camera array. On top of Sphere in Las Vegas, not near Sphere, not next to Sphere, on top of it. At the highest point above the LED displays, positioned like a freckle on the perfect outer skin of the world's largest and most expensive immersive entertainment facility. Let's talk about what Sphere actually is, because context matters here. This isn't some random building picked for telescope access. Sphere is a statement, a monument to excess and ambition, built at a cost that could fund a medium-sized space mission, 112 meters high. 157 meters wide, a perfect hemisphere covered in 54,000 square meters of LED displays, making it the largest screen on Earth. Inside, 17,600 seats, immersive audio systems with beamforming and wavefield synthesis,
haptic feedback built into the chairs so you can feel the content vibrating through your body. It opened in September 2023 with a U2 concert series and has since hosted everything from corporate events to experimental films rendered at resolutions that make IMAX look quaint. And now, sitting on top of all that spectacle, invisible to the crowds gawking at the exterior displays, there's an array of cameras pointed at the sky, recording everything that moves, tracking everything anomalous, feeding data into machine learning algorithms designed to separate drones from birds, from airplanes, from satellites, from things that don't fit any category. Loeb describes the installation like it's a perfectly natural thing to do.
His team, led by Ezra Kelderman, Alex DeLuca, Lily Kwan, and Eric Mason, spent weeks hauling equipment to the roof, mounting camera arrays in both infrared and visible wavelengths, calibrating sensors, testing tracking algorithms. He talks about climbing to the top during installation, looking out over Las Vegas from a vantage point few people ever see, and telling his team, "If you can make it to the top of Sphere, you'll make it anywhere." Cute line. But the subtext is what matters. Why Sphere? Why now? Why Las Vegas? The official explanation makes sense on the surface. Sphere provides height, giving the cameras an unobstructed view of a huge volume of airspace. Las Vegas has clear skies most of the year, minimal cloud cover, perfect for optical observation.
The city sits in a desert valley surrounded by restricted military airspace, including Nellis Air Force Base and the Nevada Test and Training Range areas, known for experimental aircraft testing. And if you believe the folklore, occasional sightings of things that move in ways conventional aircraft shouldn't. If you're looking for anomalies, Las Vegas is ground zero. But there's another reason nobody says out loud. Sphere belongs to Madison Square Garden Entertainment, run by Jim Dolan as executive chairman and CEO. When Dolan and Jane Rosenthal, CEO of Tribeca Enterprises, showed up at Loeb's door in September 2024 with an offer to build a Galileo Project observatory on top of their $2.3 billion venue, they weren't just offering telescope space. They were offering legitimacy, cover, institutional backing from entities with deep pockets and mainstream credibility. You can call Loeb a fringe scientist all you want. Accuse him of chasing aliens for publicity. Dismiss his theories as academic attention-seeking. Much harder to do that when major entertainment corporations are funding his research and giving him access to premium real estate for his instruments. The Sphere installation isn't just one observatory. It's three. The main array sits on top of Sphere itself, highest point, best vantage. But the Galileo team also installed two other identical copies of the system located 10 kilometers away, positioned at the corners of the base of a triangle. 3 observatories. 3 different viewing angles, same volume of sky. This is called triangulation, and it's the only way to get accurate 3-dimensional tracking of objects in the air. With one camera, you can see something moving, but you can't tell how far away it is. Distant, slow object looks the same as close, fast object. You need multiple viewpoints separated by known distances observing the same target simultaneously. Then you can calculate actual position, actual velocity, actual acceleration. The geometry gives you truth, so when the Galileo project talks about detecting unidentified anomalous phenomena over Las Vegas, they're not just spotting lights in the sky and guessing. They're getting precise measurements, position accurate to meters, velocity vectors with directional components, acceleration profiles showing whether an object is under power or coasting, and most importantly, they're filtering out everything mundane. Drones have characteristic flight patterns, limited speed ranges, predictable altitude caps. Helicopters show up on transponders and move in ways constrained by rotor physics. Airplanes follow approach corridors and FAA regulations. Satellites pass overhead in predictable orbits with known timing. Birds fly like birds. Insects swarm like insects. Balloons drift with the wind. The machine learning algorithms know all of this. They've been trained on millions of examples of ordinary objects doing ordinary things.
When something moves outside those performance envelopes, when acceleration exceeds what human-made propulsion can deliver, when objects make 90-degree turns at speeds that would pulverize any physical structure, when things hover motionless for extended periods, with no visible means of support, the system flags it. Not as proof of extraterrestrial technology, not yet, but as genuinely anomalous. Something worth investigating further. Loeb estimates the system will analyze data on a few million objects per year. Most will be mundane. Commercial jets, private planes, drones, satellites, the endless traffic of a sky above a major city. But statistical anomalies exist. Outliers happen. And in those outliers, buried in terabytes of positional data and spectral analysis, might be the first unambiguous evidence that we're not the only technological civilization currently operating in near-Earth space. The timing of the announcement matters as much as the content. October 24th.
5 days before 3I Atlas reaches perihelion. 4 days after amateur astronomers proved the object would be visible during its closest approach. 3 days before institutional protocols finish falling into place. Loeb goes on the world's biggest podcast and casually mentions that he just installed the most sophisticated UAP detection system ever built, capable of tracking anomalies over one of the busiest and most watched cities in America, right as an interstellar visitor swings through our inner solar system exhibiting behavior that challenges natural explanations. You could call that coincidence. You could also call it preparation. If 3I Atlas does something unusual tomorrow, if course corrections happen or smaller objects deploy or any of the technological scenarios play out, Las Vegas will be watching. The Sphere Array will record it. And unlike government installations with classified protocols and restricted data access, the Galileo project operates in the open. Academic transparency, published results, data available for independent verification. Whatever they see, will know about it. There's something almost poetic about using Sphere for this purpose. The building was designed for spectacle, for overwhelming the senses with light and sound and carefully choreographed illusion. Inside, you can watch anything the producers want you to see. Outside, covered in the world's largest video screen, Sphere can project any image, any message, any reality the operators choose. But on top, hidden from the crowds, immune to the spectacle, scientific instruments point at the actual sky, recording actual events, measuring actual physics. Truth hiding above illusion. Reality sitting on top of fantasy. Loeb talked about another detail during the podcast that deserves attention. Tomorrow, October 25th, he's attending a NASCAR race at Kern County Raceway Park in Bakersfield, California, where driver Alex Laba is racing a car featuring the Galileo Project logo, 3I Atlas imagery, and Loeb's face printed on the vehicle. Full branding, mainstream exposure, racing culture meets astrophysics. And according to Loeb, he might get the chance to drive the car himself during practice sessions. Helmet and suet and all. Physicist turned race car driver for an afternoon. On the surface, this looks like outreach, public engagement, making science accessible. But there's strategy here too. When you put your research on a NASCAR vehicle, when you show up at tracks and sign autographs and talk to fans who might never read an academic paper, you're building a constituency. People who care about the work. People who will demand answers if data gets suppressed, or findings get classified, or institutions try to bury results that challenge comfortable assumptions. You're creating pressure from below, grassroots interest that's harder to ignore than purely academic curiosity. The Sphere Observatory represents the same strategy scaled up. It's public science, funded by private entities, operating in plain sight. Impossible to classify without explaining why classified observation of Las Vegas airspace suddenly became a national security priority. If the Galileo project detects something genuinely anomalous over Nevada, something that moves beyond human technological capabilities, that data will be published, analyzed by independent researchers. You can't retroactively classify it without admitting that unclassified observations stumbled onto something you've been keeping secret. This is exactly the kind of pressure that forces disclosure, not dramatic whistleblowers making unverifiable claims, not leaked documents with suspicious provenance, just good instruments, good data, good analysis, and public access. If it's real, if objects in our airspace demonstrate technological capabilities beyond what we can build, multiple independent observation networks will eventually catch them on camera, triangulated, measured, undeniable. And when that happens, when the evidence becomes overwhelming, secrecy becomes impossible. We're already seeing hints of what that pressure looks like. Congressional hearings on UAP sightings have intensified over the past 2 years. Military personnel are coming forward with testimony about objects that violated restricted airspace and demonstrated performance characteristics that don't match any known aircraft. Pentagon officials are being grilled about lack of transparency, the all-domain anomaly. Resolution Office exists now specifically to investigate these reports, even if their conclusions remain frustratingly vague and their funding remains questionable. But ARO operates within the classified world. They can investigate, but their findings can be locked behind security protocols redacted, withheld from public analysis. The Galileo project doesn't have that limitation. When they detect something, when their cameras track an object performing maneuvers that challenge physics as we understand it, that information goes straight to peer review. Publish papers, open data repositories. Anyone with the expertise can verify the analysis, check the math, confirm or refute the conclusions. That's the real threat to secrecy, not hackers or leakers, just good science operating in daylight. Impossible to suppress without revealing that suppression is happening. What happens tomorrow morning becomes more interesting in this context. 3I Atlas reaches perihelion at 11:36 Universal Time. Multiple observatories around the world will be watching, weather permitting. Amateur astronomers with backyard telescopes, professional facilities with research-grade instruments, space-based assets like the James Webb Telescope and Hubble, European Space Agency missions, all of them recording data, all of them noting what happens. And now, sitting on top of Sphere in Las Vegas, the Galileo Project Array will be watching too. Not the interstellar object itself that's too far away for ground-based optical tracking in daylight, but the sky above Nevada, the space where objects might appear if something deploys from 3I Atlas, the volume where probes would become detectable if they use the sun's gravitational assist to redirect toward inner-system targets. If mini-probes launch tomorrow, if the mothership hypothesis plays out, and 3I Atlas releases smaller craft during perihelion passage, some of those objects might head toward Earth. Reverse Oberth maneuvers, using thrust at perihelion to slow down and drop into bound orbits. And when they arrive weeks or months from now, they'll pass over cities, over deserts, over Las Vegas, where cameras will be waiting.
One final detail from the podcast matters. Loeb mentioned that the NASCAR race he's attending tomorrow happens the same day as perihelion. October 29th. Morning astronomical event, afternoon racing event, physicist at the track, while history potentially unfolds 200 million kilometers away. There's symbolism in that. Speed and precision, risk and observation. Human engineering at its limits, right as we potentially witness engineering from beyond those limits. What happens in Vegas usually stays in Vegas, or so the saying goes, but what happens over Vegas, recorded by scientific instruments, analyzed by machine learning, verified by triangulation, that won't stay anywhere. That goes into the permanent record. That becomes data we can't ignore. While 3I Atlas captures attention with its dramatic approach, The James Webb Space Telescope continues revealing universes within the universe we thought we understood.
Every image it captures, every spectrum it records, every observation it makes seems designed to humble our assumptions about cosmic order. The latest discoveries arrived just days ago, almost as if the cosmos wanted to remind us that mysteries don't require interstellar visitors. Sometimes they're baked into the structure of reality itself, hiding in plain sight, waiting for instruments sensitive enough to notice. October 27, 2025, two PhD students from the University of Sydney published software that restored the telescope's crystal-clear vision after discovering subtle electronic distortions affecting one of Webb's instruments. Louis Desdois and Max Charles developed an artificial intelligence-driven system called Amigo that corrects image blurring in the infrared camera fixing problems that would normally require astronauts visiting the telescope in space for physical repairs. Except Webb orbits 5 million kilometers from Earth at the second Lagrange point L2, completely unreachable by human missions with current technology. What breaks at L2 stays broken unless you can fix it remotely. The problem involved the aperture masking interferometer, the only Australian-designed component on Webb created by Professor Peter Tuthill, specifically for ultra-high-resolution imaging of stars and exoplanets. The instrument works by combining light from different sections of Webb's main mirror using interferometry to achieve angular resolution far beyond what the mirror diameter alone would provide. But faint electronic distortions in the infrared detector were degrading performance, introducing artifacts that blurred fine details and reduced effective resolution. Traditional approaches to fixing this would involve uploading new calibration files or adjusting instrument parameters. Iterative process. Taking months potentially, never reaching optimal performance. Desdois and Charles took a different approach. Train machine learning algorithms to recognize the distortion patterns, model how light should actually look without electronic interference, reconstruct true images from degraded data. The AI learned what real sky looks like versus what detector artifacts look like, separated signal from noise, recovered detail that was there in the photons but getting lost in conversion to electronic data. The results are spectacular. Galaxy NGC 1068, Jupiter's moon Io Wolf-Rayet star 137, all previously captured with slight blur, now rendered in perfect clarity with detail visible down to the diffraction limit of the telescope. This isn't enhancement in the science fiction sense where computers magically reveal hidden information. This is correction, removing known sources of degradation, restoring what the telescope actually saw before electronics corrupted it. And this matters enormously for 3I Atlas observation.
Webb looked at the interstellar visitor back on August 6th with its near-infrared spectrograph instrument. The spectroscopy revealed that extreme carbon dioxide to water ratio, the 8:1 composition that makes the object so unusual. But spectroscopy is just one capability. Webb can also image in infrared wavelengths invisible to visible light telescopes, capturing thermal emission and reflected starlight in ways that reveal structure geometry details that might distinguish natural from artificial. If Webb turns toward 3I Atlas again post-perihelion, if the observatory dedicates time to detailed infrared imaging, using the now perfectly calibrated interferometer, we might see things no other telescope can capture, surface features, if any exist, geometric patterns in the coma that suggest organized rather than chaotic emission, thermal signatures that don't match simple solar heating, small secondary objects, if anything, deployed during perihelion passage.
The level of detail Webb can achieve, especially with Amigo correcting for instrumental artifacts, approaches what you'd need to definitively characterize unusual morphology. But while the Sydney team fixed Webb's vision, the telescope itself kept making discoveries that challenge everything we thought we knew about cosmic history. 300 galaxies that shouldn't exist, That's what astronomers at the University of Missouri found when analyzing deep field images from Webb's infrared camera. Objects in the early universe formed within the first billion years after the Big Bang, appearing far brighter than they have any right to be. Standard galaxy formation models say you start with dark matter, gravitational wells pulling in hydrogen and helium, gradual accumulation, slow ignition of first stars, millions of years to build substantial stellar populations. Early galaxies should be small, dim, struggling to accumulate mass against the expansion of space itself. These objects are none of that. They're luminous, massive, structured in ways that require mature stellar populations and significant time to develop. Time they shouldn't have had. If the universe is 13.8 billion years old and these galaxies appear as they were, 13 billion years ago they had maybe 700 million years to form. Not enough time under current models. Not nearly enough. Huangqing Chen, astronomy professor at Missouri and co-author on the study, calls them candidate galaxies because confirming their nature requires follow-up spectroscopy that hasn't been completed yet. They could be very early galaxies that force revision of formation theories, or they could be something else entirely. Bright quasars, unusual dust emission, foreground contamination that looks like distant objects but isn't. Science requires confirmation before revolution. But if even a fraction of these 300 objects turn out to be actual galaxies at the distances their brightness suggests, we have a problem. A beautiful problem, the kind that overturns textbooks and launches decades of new research, but a problem nonetheless. You can't form massive bright galaxies in 700 million years using processes we understand. Either dark matter behaved very differently in the early universe, clumping much faster than models predict, or star formation was far more efficient than current physics allows, or something else entirely was going on that we haven't theorized yet. This is the third or fourth time Webb has found objects that defy standard cosmology. First, there were the little red dots, compact, extremely luminous sources that might be galaxies, or might be a new class of object called black hole stars, where entire stellar masses get trapped in accretion disks around supermassive black holes. Then there were the impossibly mature galaxies at cosmic dawn, showing heavy element abundances that require multiple generations of stellar evolution, despite appearing only a few 100 million years after the Big Bang. Now 300 more objects too bright for comfort. A pattern starts to emerge. Either our timeline for cosmic structure formation is completely wrong, compressed by factors we don't understand, or the early universe was fundamentally different from the later universe in ways that current theory doesn't capture. Hot Big Bang cosmology works spectacularly well for explaining cosmic microwave background element abundance's large-scale structure today. But maybe the first billion years operated under different rules that we can't directly observe because light from that era is only now reaching us in wavelengths infrared enough for Webb to detect. Meanwhile, Webb found interstellar dust with structure so fine it looks like wood grain. Knots and whirls and layers like an onion revealed when the telescope imaged light echoes from Cassiopeia, a supernova. The star exploded 350 years ago. The blast wave has been expanding ever since and recently reached interstellar material that wasn't part of the original explosion. When that flash of X-rays and ultraviolet light hit the dust, it heated, it made it glow in infrared, and Webb captured the emission in unprecedented detail. Josh Peak from the Space Telescope Science Institute describes seeing structure on scales of 400 astronomical units, less than 1/100th of a light year, sheet-like formations, tightly packed filaments, structures so organized they look like they must be shaped by magnetic fields threading through the interstellar medium. We knew interstellar space wasn't empty, knew it was full of gas and dust, but we didn't know that dust had architecture. Organization down to incredibly small scales,
Geometry that suggests forces we barely understand.
sculpting the matter between stars into forms we're only just beginning to see. This matters for 3I Atlas because the object is shedding mass. 2 million tons of material lost between July and October as solar heating sublimates surface layers. That material doesn't vanish. It becomes part of the interstellar medium, microscopic ice fragments and dust grains drifting through space, contributing to the architecture of the galaxy. If 3I Atlas is natural, its dust joins the ordinary interstellar material that Webb sees organized into sheets and knots. If it's artificial, the dust might have signatures, unusual composition or isotope ratios or grain sizes that don't match natural solar system formation. Decades from now, when that dust disperses, some of it will still be out there, potentially identifiable. Potential evidence of the object's nature preserved in particles scattered across light years.
The universe Webb reveals is messier than we expected, more chaotic in some ways, more structured in others. Galaxies form faster than they should, get brighter than they should, contain heavy elements sooner than they should. Interstellar dust organizes into geometric patterns, despite being influenced by turbulent flows and magnetic chaos. Black holes exist in the earliest epochs, when there shouldn't have been time for them to grow supermassive. Stars explode and leave echoes that illuminate architecture we never knew existed. Every answer generates more questions. Every observation opens new mysteries. And running through all of it is the uncomfortable recognition that we understand maybe 5% of what the universe contains. Dark matter makes up most of the mass. Dark energy drives accelerating expansion, normal matter. The stuff we're made of, the atoms that form stars and planets, and people, represents a small minority of cosmic inventory. And even that small minority behaves in ways we struggle to predict when we look at scales Webb can now access. This is the context for 3I Atlas. An interstellar visitor arriving in a universe that's already mysterious, already full of phenomena we can't explain with standard physics, already demonstrating that our theories work well locally but struggle with extremes of time and distance and energy. If the object turns out to be artificial, it'll be surprising, but not uniquely impossible. Just another thing the cosmos can do that we didn't anticipate, another way intelligence manifests in a universe that seems designed to produce complexity, despite or because of physical laws we think we understand. But even if 3I Atlas is natural, even if tomorrow brings conventional comet behavior and the technological hypothesis evaporates, we're still left with a universe that contains 300 impossibly bright galaxies, dust organized like living wood, early black holes that shouldn't exist, and formation timelines that violate our best models. The mystery doesn't depend on aliens. It's baked into the structure of space and time and matter. Webb gives us the tools to see that mystery in detail: infrared sensitivity, spectral resolution, angular precision, distance reach that brings the edge of the observable universe into focus. Every technical advance reveals more questions, and the telescope has barely begun its operational life. 20 years of observation time ahead, decades of discoveries waiting, fields of view we haven't targeted yet, objects we haven't noticed yet, phenomena we don't have names for yet. And somewhere in those future observations, maybe we'll find more interstellar visitors, objects like 3I Atlas passing through, some natural, some potentially artificial, all carrying information about planetary systems we'll never visit, and stellar neighborhoods we can only study through the emissaries they send our way. Statistics suggest 1 or 2 interstellar objects per year should pass close enough for detailed study if our detection capabilities are good enough. Webb makes those capabilities better. Ground-based observatories continue improving. Survey telescopes scan larger volumes of sky with greater sensitivity. The golden age of interstellar visitor detection is just beginning. 3I Atlas is the third we've confirmed, But it won't be the last, and as our characterization improves, as spectroscopy and imaging and trajectory analysis become routine for every detection, we'll build a catalog: natural versus artificial, compositions, trajectories, size distributions. Enough data points to draw statistical conclusions about what travels between stars and whether intelligence is part of that traffic. That's the real test. Not one object, not 3i Atlas in isolation, but dozens or hundreds of interstellar visitors studied over decades, analyzed for patterns, compared against theoretical predictions for both natural and artificial populations. If technological probes exist, if civilizations send scouts between stars at rates higher than natural ejection produces random comets and asteroids, the statistical signature will emerge: too many visitors with suspicious trajectories, too many alignments with ecliptic planes and planetary encounters, too many anomalies that individually might be chance but collectively indicate design. We're not there yet. We don't have enough data, but we're approaching the threshold where statistical arguments become possible, where catalog science replaces case studies, where patterns override individual ambiguity. Tomorrow, 3i Atlas adds another data point: natural or artificial, conventional or anomalous, explicable or mysterious. The measurement gets recorded, the data joins the archive, and the universe continues revealing itself layer by layer, mystery by mystery, one observation at a time. Tomorrow morning at 11:36, Universal Coordinated Time, when 3i Atlas swings around our sun at its closest approach, we'll witness something extraordinary. Not because we know what will happen, but because for the first time we'll actually be watching. For months we were told it would be invisible, hidden behind solar glare, unobservable during the most critical moment of its journey through our neighborhood. But amateur astronomers refused to accept that narrative without verification. They pointed their telescopes at the sky and proved that visibility was never the issue. What was the issue then? Why construct a story about invisibility if observation was always possible? Maybe it was innocent. Maybe orbital calculations were uncertain, and institutions erred on the side of caution, assuming solar conjunction would be more severe than it turned out to be. Or maybe someone wanted time to prepare, time to coordinate, time to ensure that if 3i Atlas did something unexpected, something that challenged the comfortable assumption that interstellar visitors are always natural, the response would be controlled, managed, measured. We may never know which explanation is correct, but tomorrow the question becomes less relevant. Because tomorrow observation happens regardless of whether anyone wanted it to. Telescopes will track, sensors will record, data will accumulate, and physics will tell us what 3i Atlas actually is. Not what we hope it is, not what we fear it might be, what it is. Let me summarize what we know for certain, separated cleanly from speculation. 3i Atlas is real. It's the third confirmed interstellar object to pass through our solar system, discovered on July 1, 2025, approaching from beyond the outer planets on a hyperbolic trajectory that traces back to interstellar space. It exhibits 8 anomalies that challenge simple natural explanations. Trajectory alignment with the ecliptic plane at just 5 degrees inclination. Close encounters with 3 planets: Venus, Mars, and Jupiter. Solar conjunction timing that was supposed to hide perihelion from observation. An anti-tail phenomenon showing material ejected toward the sun. Nickel emissions without corresponding iron signatures. Extreme carbon dioxide dominance with an 8:1 ratio to water. Early activation at 6.4 astronomical units. Geometric emission patterns in the coma. Each anomaly individually has natural explanations. Unusual but possible conditions. Edge cases that happen rarely but legitimately. Together, the compound probability becomes statistically improbable, though not impossible. Amateur astronomers documented trajectory deviations requiring nearly 4 kilometers per second of lateral velocity change. position offsets reaching 15.4 arc minutes from JPL predictions. Brightness anomalies, showing the object both dimmer than expected overall and brightening faster than inverse square law predicts. Multiple institutional responses coincided with the object's approach. SETI updated post-detection protocols for the first time in 15 years. The International Asteroid Warning Network added 3I Atlas to their planetary defense threat list, despite it posing no collision risk. Mandatory training exercises were scheduled for November through January. The U.S. government entered a funding lapse that silenced NASA communications. In August, a quasi-satellite designated 2025 PN7 was discovered in Earth orbit, matching the trajectory of a failed 1964 Soviet Venus mission, but lacking spectroscopic confirmation of composition. The timing, like so much else this year, feels significant. In October, the Galileo project installed all-sky camera arrays on Sphere in Las Vegas, creating a triangulated observation network capable of tracking anomalous objects with unprecedented precision. The James Webb Space Telescope received software upgrades that restored perfect vision to its instruments. Congressional hearings on UAP transparency revealed whistleblowers facing career retaliation for reporting encounters with objects demonstrating capabilities beyond known human technology. These are facts, documented, verifiable, not speculation. What remains unexplained is what it all means. Whether the patterns we see are patterns of reality or patterns of perception. Whether 3I Atlas is natural comet from another star system or technological probe from a civilization that achieved interstellar travel before Earth had written language. The technological hypothesis isn't proven. It's not even probable by most scientific assessments. But it's not dismissed either. It remains on the table as a legitimate possibility that deserves investigation proportional to its implications. Avi Loeb assigns it a 4 out of 10 on his scale for artificial origin. Not alien confirmed, just anomalous enough that ignoring the possibility requires ignoring evidence that doesn't fit comfortable narratives. Tomorrow, the balance might tip. One way or the other. If 3I Atlas behaves like a natural comet at perihelion, the technological hypothesis weakens dramatically. You could still argue the probe is deliberately mimicking natural behavior to avoid detection, but at that point, you're invoking conspiracies to save hypothesis, and science doesn't work that way. If it looks like a comet, acts like a comet, and shows no sign of capability beyond what comets can do naturally, the simplest explanation is that it's a comet. Unusual composition, unusual trajectory, unusually well positioned for observation but still natural. However, if tomorrow brings anything unexpected, if course corrections happen, or brightness spikes occur, or geometric patterns emerge, or secondary objects deploy, if any of those observations require technological capability to explain, then the conversation shifts immediately. Not to proof. Not yet, but to serious scientific investigation of the possibility that we're watching artificial hardware transit our solar system. That investigation would involve dedicated tracking missions, interception attempts if feasible, intensive spectroscopy, searching for industrial signatures, radio monitoring for communication signals. Everything we can throw at the problem to confirm or refute artificial origin. That's what's at stake tomorrow. Not public disclosure or government announcement or any of the dramatic scenarios that conspiracy theories love. Just data. Measurements that either support natural explanation and let us move on, or challenge natural explanation and demand deeper investigation. Either outcome advances our understanding. Either way, we learn something important about what travels between stars and how common that travel might be. Let me close with a question. Not a rhetorical one. A genuine question that you should consider as we approach this moment. Tomorrow morning at 11:36 UTC, when 3I Atlas swings around our sun at its closest approach, will we witness the behavior of a natural comet, following ancient physics, teaching us about planetary formation in distant star systems and the composition of interstellar ice? Or will we catch a glimpse of something that proves the universe has been alive with intelligence all along, and we've just been too young, too isolated, too primitive to notice? Until now, I don't know the answer. Nobody does. That's why tomorrow matters. That's why observation is essential. That's why amateur astronomers who refuse to accept the invisibility narrative might have done more for human knowledge than they realize. The universe doesn't care what we believe. It is what it is. Our job is simply to watch carefully enough to see it clearly. And tomorrow we watch. Every telescope that can point toward that region of sky. Every amateur astronomer with equipment and clear weather. Every professional observatory with instruments capable of characterizing behavior at perihelion. No darkness, no hiding. Just physics playing out in real time with witnesses. Whatever happens, we'll record it. Whatever 3i Atlas does, the data will exist in multiple independent archives available for analysis by anyone with expertise and interest. Truth doesn't need permission. Evidence creates its own pressure. And the universe, patient and eternal, continues revealing its secrets one careful observation at a time. So watch the sky tomorrow. Pay attention to what emerges in the days and weeks that follow. And remember that the greatest discoveries often come not from finding answers, but from learning to ask better questions. Are we alone, or are we one voice in a chorus so vast and scattered that hearing each other requires patience and technology and luck? We're only beginning to develop. 3i Atlas might not answer that question definitively, but it might move us closer to the threshold where the answer becomes undeniable. And isn't that worth watching for good night? Sleep well. And when you wake tomorrow, know that the universe might look different than it did today. Not because it changed, because we finally learned to see it clearly.